A lone star is running through the deep shadows of our galaxy right now like a fugitive escaping the scene of a cosmic crime. It carries the ancient chemical mark of a world that was violently destroyed billions of years before our sun was born. Astronomers are currently tracking its unbelievable speed as it races through space on a path that breaks every law of galactic history. It is flying completely alone, silently holding the secret of how it survived the total collapse and death of its own parent world. If you want to discover the most incredible real mysteries of deep space without any exaggerated nonsense, hit the subscribe button right now and turn on all notifications. Joining our channel today ensures you will never miss a single deep dive into the true secrets of our universe. To understand why this discovery completely shocked the scientific world, we first have to look at how stars and galaxies are supposed to work together. A galaxy is a massive cosmic city made of hundreds of billions of stars, giant clouds of dust, and vast amounts of hydrogen gas, all held together by gravity. Under normal rules, a galaxy forms very early in cosmic time and continues to exist almost indefinitely as a permanent nursery. Inside this massive cosmic city, many generations of stars are born, live out their lives, and eventually die over billions of years. Stars come and go like individual residents in a big city, but the galaxy itself remains standing strong as the permanent home that outlives them all. For more than a century, astronomers operated under the strict belief that no single star could ever outlive the galaxy that created it. When a new star ignites inside a young galaxy, it is bound to that galactic neighborhood by powerful gravitational forces that pull on everything inside. The galaxy provides the raw gas needed for the star to shine, and when that star eventually burns through its core fuel, it collapses or explodes right inside that same galactic territory. Because a galaxy contains so much total mass and energy, scientists believed a galaxy would always survive long after its original founding stars had burned out and vanished into dark space. That basic rule of astronomy completely fell apart when researchers pointed their telescopes toward a faint, ordinary-looking point of light known as star HD 1229+1122. Sitting roughly 190 light-years away from Earth in the constellation of Libra, this star looks completely unimpressive to anyone looking through a normal backyard telescope. It shines with a steady, quiet yellow light and moves slowly across our night sky without making any sudden flares, flashes, or dramatic visual displays. But when astronomers began studying the actual light coming from this humble object, they realized they were staring directly at something that should not exist in our modern neighborhood. When scientists want to understand the true nature of a distant star, they split its light into a rainbow spectrum to examine its chemical fingerprint. Every chemical element inside a star leaves distinct dark lines across this spectrum of light, allowing astronomers to read what the star is made of with extreme accuracy. Younger stars like our sun are packed with heavier elements such as iron, carbon, oxygen, and silicon, which were forged inside older generations of giant stars that exploded long ago. When those ancient stars died in massive supernova explosions, they scattered those heavy metals into space, enriching the gas clouds that formed newer stars like our sun. This chemical makeup serves as a reliable cosmic clock that tells scientists exactly when and where a star was born. A star that contains a high amount of iron must have been born recently inside a mature galaxy that has already seen many generations of stellar birth and death. On the other hand, a star with almost no iron or heavy metals must have been created near the absolute beginning of time, when the universe was filled with nothing except raw hydrogen and helium gas. Scientists fully expected a nearby star sitting close to our sun to have a rich mix of heavy metals gathered over billions of years of Milky Way history. What researchers actually discovered inside HD 1229+1122 left the global scientific community completely stunned and scrambling for answers. When astronomers carefully measured the chemical lines in the star's spectrum, they found that it contained less than 1/250th of the iron content found inside our own sun. It was almost entirely devoid of heavy metals, made almost purely of primeval hydrogen and helium left over from the dawn of creation. This massive gap between what scientists expected and what they actually measured proved that HD 1229+1122 was not a normal Milky Way star, but an ancient fossil from a long-lost era. Did you know that astronomers can figure out the exact age and chemical history of a star just by breaking its light into a rainbow? If learning how scientists unlock these secret cosmic fingerprints fascinates you, leave a like on this video right now and comment below if you have ever searched for the constellation Libra in the night sky. The discovery of this metal-poor star immediately launched a massive global investigation to figure out its true age and origin story. In the year 2000, European researchers used data from the Hipparcos satellite to calculate how far away HD 1229+1122 was from our solar system. Distance is the single most important number in astronomy, because knowing the exact distance allows scientists to work out a star's true intrinsic brightness. Once you know how brightly a star actually shines on the inside, You can feed that information into stellar physics models that calculate how fast the star is burning its nuclear fuel. When the research team plugged the satellite distance numbers into their computer models, the calculated age for HD 1229+1122 came out to a mind-boggling 16 billion years old. This result instantly created a giant panic across the world of astrophysics because it produced a broken scientific paradox that seemed to defy physical reality. Precise measurements of cosmic background radiation proved that the Big Bang happened 13.8 billion years ago, marking the absolute beginning of our universe. A single star cannot possibly be 16 billion years old if the entire universe itself is only 13.8 billion years old. This huge contradiction meant that either our core understanding of how the entire universe began was completely wrong, or there was a deep hidden mistake in how scientists were measuring this star. Researchers quickly gave HD 1229+1122 the popular nickname of the Methuselah star, named after the famous long-lived figure from ancient history, and set out to solve the puzzle. A leading team of astronomers, led by Dr. Howard Bond from Pennsylvania State University, decided to use the powerful Hubble Space Telescope to re-examine the star with ultimate visual precision. Dr. Howard Bond's team used Hubble to track the tiny back-and-forth shift of the star against background galaxies as Earth moved around the Sun, a method called trigonometric parallax. By making extremely accurate position measurements over several years, they calculated the exact distance to HD 1229+1122 with far better accuracy than any satellite had ever achieved. They also discovered that the star was burning through its remaining core hydrogen slightly faster than earlier models assumed, meaning it was slightly more luminous and therefore somewhat younger than the initial scary estimate suggested. After years of complex mathematical calculations and checking every detail of stellar physics, Dr. Bond and his team published their groundbreaking New Age measurement. They determined that the Methuselah star was approximately 14.46 billion years old, but with an official measurement uncertainty of plus or minus 800 million years. Taking the lower end of that uncertainty range brought the star's minimum possible age down to roughly 13.66 billion years old. That crucial adjustment finally placed the star just under the 13.8 billion year age of the universe, barely fitting it into the accepted timeline of cosmic history. Here is the vital detail that most people overlook when thinking about this impossible timeline. Even at its lowest possible age of 13.66 billion years, the Methuselah star was born just a few hundred million years after the Big Bang occurred. It was formed during a primeval era when the very first primitive stars were lighting up the dark cosmic void long before our Milky Way galaxy had built its famous spiral arms. That unbelievable age raised a massive new question that kept astronomers awake at night. Where was this star actually created if the Milky Way galaxy did not even exist yet? Have you ever wondered what the night sky would look like from a planet orbiting a star that was born at the beginning of time? Tell us what you think in the comments section below. And if you are enjoying this deep dive into real space mysteries, take a quick second to hit the subscribe button so you never miss our daily space uploads. To solve the mystery of where HD 1229+1122 came from, astronomers had to look beyond its age and study how it moves through space today. Most of the hundreds of billions of stars in our galaxy orbit neatly inside the flat, rotating disk of the Milky Way, moving like cars, staying in designated traffic lanes on a giant circular highway. Our Sun, along with almost every star visible to the naked eye, completes one full orbit around the center of our galaxy every 230 million years, staying safely inside this organized disk. When scientists tracked the movement of the Methuselah star using advanced space observatories, like the European Space Agency's Gaia satellite, they discovered an astounding motion pattern. HD 1229+1122 does not follow the orderly circular highway of the Milky Way disk at all. Instead, it travels on a steeply tilted oval-shaped bullet-like orbit that dives straight through the galactic plane and rockets far out into the vast spherical halo surrounding our galaxy. It travels at a terrifying speed of over 800,000 miles per hour relative to our solar system, slashing through our space neighborhood like a cosmic stranger passing through town. Scientists originally assumed that any neighbor star sitting close to our Sun must be a native-born member of the Milky Way's core family. But its crazy high-speed orbit, combined with its total lack of heavy metals, revealed a mind-blowing secret about its true history. HD 1229+1122 is not a native star born inside the Milky Way, but an extragalactic immigrant that survived a terrifying period of cosmic warfare. It was born inside an ancient primeval dwarf galaxy, a small mini-galaxy that existed in the early universe long before our home galaxy expanded to its current size. More than 12 billion years ago, as the young Milky Way was rapidly growing larger, its giant gravitational field began pulling in smaller neighboring galaxies like an unstoppable monster. The primeval dwarf galaxy that birthed HD 1422H3 was drawn directly into a fatal gravitational trap. As the dwarf galaxy drifted closer to the massive Milky Way, extreme gravitational tidal forces began stretching it out, tearing its structure apart, and pulling millions of its stars out of their original home in an act of cosmic cannibalism. Over hundreds of millions of years, that entire dwarf galaxy was violently shredded, crushed, and completely destroyed, its gas clouds turned inside out, and its identity erased forever. The original home galaxy of HD 142283 ceased to exist, completely eaten and digested into the growing mass of the early Milky Way. Yet, against impossible mathematical odds, HD 142283 survived that catastrophic galactic death without being swallowed by a black hole or smashed in a stellar collision. It was hurled out of its dying galaxy and left to wander through the Milky Way's outer halo as a lone survivor. Can you imagine an entire galaxy filled with millions of stars being completely destroyed while one single star keeps flying safely through space? If this mind-blowing survival story gives you chills, give this video a thumbs up right now and comment below with your favorite cosmic theory so we can keep discussing it together. To truly understand how a star could survive the complete destruction of its home world, we have to examine what actually happens when two galaxies collide in deep space. People often picture galactic collisions like two car crashes, where solid objects smash into each other and shatter into tiny pieces. But in reality, a galaxy is mostly empty space, with enormous distances separating individual stars. For example, if our sun were scaled down to the size of a tiny marble, the nearest neighboring star would be located over 100 miles away. Because space is so ridiculously empty, when two galaxies crash into each other, the individual stars almost never hit each other directly. Instead, the collision is fought entirely through invisible forces of gravity that act like giant cosmic hands reaching into the smaller galaxy. As the massive Milky Way pulled on the smaller dwarf galaxy, the gravity pulled far harder on the near side of the dwarf galaxy than on the far side. This massive difference in gravitational pulling force created intense tidal stretch, pulling the smaller galaxy apart like soft clay. As the dwarf galaxy was stretched out into a long ribbon of stars and gas, its delicate internal balance was destroyed forever. Gas clouds that were once peaceful nurseries for new stars were violently squeezed, causing massive bursts of short-lived star formation followed by total gas depletion. The gravitational pull of the growing Milky Way stripped away all the remaining free hydrogen gas, effectively cutting off the fuel supply needed to create any future generations of stars inside that dwarf world. The dwarf galaxy was completely sterilized, losing its ability to ever give birth again. While the gas was being stripped away, the stars that already existed were violently flung into new chaotic paths across the dark void. Many stars were pulled directly into the central region of the Milky Way, where they were swallowed by the growing core or trapped in tight orbits close to massive black holes. Other stars were flung violently outward into intergalactic space, pushed so fast that they escaped the pull of both galaxies entirely. But HD 142283 was caught in a very specific gravitational sweet spot during the final destruction of its home galaxy. It received just enough orbital momentum to escape being swallowed by the center of the Milky Way, but not enough speed to be kicked out into the freezing emptiness of intergalactic space. Instead, it was captured by the outer gravity of the Milky Way and placed on its permanent halo path. It became a cosmic ghost, continuing to shine quietly while the rest of its home galaxy was dissolved into the background star fields of our giant galaxy. It survived because it was sturdy, slow-burning, and placed on a wide trajectory that kept it away from the most dangerous collision zones. Does it amaze you that gravitational forces can destroy an entire galaxy without its individual stars actually crashing into one another? Tell us how you feel about these invisible cosmic forces in the comments section below. And if you have not subscribed yet, make sure to click that subscribe button right now to support our independent space channel. The story of HD 14283 becomes even more disturbing when you realize that galaxy destruction is not just an ancient historical event from the past, but an active reality happening right now. As you read these words, our Milky Way galaxy is actively hunting, tearing apart and digesting several smaller dwarf galaxies that wandered too close to our boundary. Right now, the Sagittarius dwarf spheroidal galaxy is being pulled apart into long threads of stars by our galaxy's massive gravitational grip, leaving ghostly streams of lost stars wrapped around our galactic center like cosmic ribbons. Astronomers studying these stellar streams can trace the exact paths of dying galaxies as they are torn apart over millions of years. Using advanced space telescopes, scientists have identified dozens of distinct streams of stars looping around the Milky Way like giant invisible highways. Every single one of these stellar streams represents the scattered remains of a ruined dwarf galaxy that was devoured by our Milky Way monster. Millions of stars inside those streams are currently living through the exact same nightmare that HD 1229+1122 survived billions of years ago. In some cases, stars are launched out of galactic collisions at speeds so extreme that they seem to break every normal rule of space movement. Consider the astonishing case of the hypervelocity star known as S5-AHV-S1, which was caught traveling through our galaxy at an unbelievable speed of 3.7 million miles per hour. That is roughly 10 times faster than most normal stars in the Milky Way, moving so fast that it easily exceeds the gravitational escape velocity of our entire galaxy. It is moving with so much raw kinetic energy that nothing in our galaxy can ever stop it or pull it back. When scientists traced the path of S5-HVS1 backward using precise computer calculations, they discovered that its flight started at the very center of the Milky Way, roughly 5 million years ago. A binary star system containing 2 stars drifted too close to Sagittarius. A star, the supermassive black hole lurking at the heart of our galaxy. The intense gravity of the supermassive black hole captured one of the stars into a tight orbit and hurled the second star outward like a giant rock fired from a slingshot. That evicted star was launched on an endless escape path through deep space. That hypervelocity runaway star is currently blasting through the outer limits of our galaxy and will soon leave the Milky Way completely behind. It will spend the rest of cosmic time wandering through the pitch-black void between galaxies, completely alone in the endless dark. Just like the Methuselah star, it represents a cosmic outcast that will outlive its physical connection to the galactic home that produced it. It proves that the universe is constantly creating lonely cosmic wanderers through sheer gravitational violence. Have you ever thought about what it would be like to look up at the night sky from a planet orbiting a hypervelocity star drifting between galaxies? Share your creative thoughts in the comments section below, and share this video with anyone you know who loves mind-bending astronomy discoveries. Another terrifying example of galaxy destruction sits 55 million light years away in the direction of the constellation Virgo. Astronomers using powerful optical telescopes discovered a giant blue supergiant star named SDSS J1229+1122. This massive star was spotted inside a long tail of glowing gas that is being violently pulled out of a small dwarf galaxy called IC3418. A massive cluster of surrounding galaxies is creating intense pressure that strips all the gas clean out of the dwarf galaxy as it travels through space at high speeds. This process, known to astronomers as ram pressure stripping, acts like a supercharged cosmic wind blowing through the dwarf galaxy. As the galaxy races through the cluster, its internal gas is pushed out behind it like smoke trailing behind a speeding rocket. Incredible physical pressure inside this trailing tail of gas causes raw hydrogen to compress and ignite, forming newborn giant stars far outside the boundaries of any galaxy. These stars are literally born in the stripped-off wreckage of a dying galaxy surrounded by empty space. The blue supergiant star SDSS J1229+1122 is one of the most isolated stars ever spotted by human eyes. It sits completely outside any normal galactic boundary, surrounded by tens of thousands of light years of total empty space. Because it is a massive blue star, it burns through its core nuclear fuel at a furious pace and will die in a brilliant supernova explosion in just a few million years. It will live its entire short life and die in absolute isolation, never knowing what it feels like to belong to a stable galactic city. These discoveries prove beyond any doubt that the universe is far more dynamic, violent, and chaotic than traditional science textbooks like to admit. Galaxies are not peaceful, eternal islands of light that last forever without changing. They are violent, growing monsters that constantly clash, merge, consume their smaller neighbors, and cast millions of innocent stars out into the freezing void. The Methuselah star, HD 1229+1122, was simply one of the very first stars to experience this galactic nightmare and survive to tell the tale. Does learning about stars born in trailing gas tails outside of galaxies change how you view the stability of our universe? Let us know what you think in the comments below, and do not forget to hit the like button right now if you are enjoying this deep scientific story. To grasp the full impact of these galactic collisions, we also have to understand how dark matter acts as the invisible puppet master behind all cosmic destruction. Dark matter is an invisible, unknown substance that makes up more than 85% of all matter in the entire universe. While we cannot see dark matter with our eyes or detect it with optical light telescopes, its massive gravitational footprint shapes how every single galaxy forms, moves, and dies. Giant spherical clouds of dark matter, known as dark matter halos, envelope every galaxy like invisible protective cages. When a small dwarf galaxy approaches a giant galaxy like the Milky Way, it is actually the invisible dark matter halos that collide and interact first. The giant dark matter halo of the Milky Way pulls on the smaller dark matter halo of the dwarf galaxy, slowing it down through a gravitational braking effect called dynamical friction. This cosmic dragging force drains the dwarf galaxy of its forward motion, forcing it to spiral closer and closer to the central monster in an inescapable death orbit. Without the crushing gravitational force of dark matter halos, many dwarf galaxies would simply sail past without being destroyed. As the dwarf galaxy sinks deeper into the dark matter halo of the giant galaxy, tidal forces peel away its outer layers step by step. First, the outer dark matter envelope is completely stripped away, leaving the inner core of visible stars vulnerable to gravitational destruction. Once that dark matter shield is gone, the star cluster loses its gravitational anchor, making it vastly easier for individual stars like HD1229+1122 and 83 to be dragged out of their orbits. Dark matter acts as both the builder that holds young galaxies together and the crushing force that pulls them apart during collisions. Understanding the role of dark matter helps explain why the Methuselah star was able to maintain its internal stability even while its home galaxy was completely unraveled around it. The star itself was dense and compact enough that its own localized gravity kept its nuclear core burning without interruption. While the diffuse gas clouds and loose outer stars of its homeworld were torn away into giant tidal streams, HD140283 remained a tight ball of burning plasma. It rode the gravitational waves of dark matter friction like a boat surviving a massive tsunami in deep water. This intricate dance between dark matter and visible stars shows that every galaxy is locked in a constant fight against invisible forces. The survival of a single star during a galactic collision is an extraordinary physics outcome that depends on exact angles, speeds, and dark matter densities. Studying these rare cosmic survivors provides astrophysicists with direct clues about where dark matter is concentrated across our galaxy. By tracking how ancient halo stars move today, scientists can build detailed maps of the invisible dark matter structure that governs our universe. Are you surprised to learn that invisible dark matter is actually responsible for pulling small galaxies into fatal traps? Let us know your thoughts on dark matter in the comments section below. And if you find these deep scientific explanations clear and engaging, take a quick second to hit the subscribe button right now. When you step back and look at the bigger picture, these dramatic galactic survival stories connect directly to our own future here on Earth. In roughly 4.5 billion years, our own Milky Way galaxy will experience a titanic collision with our nearest giant neighbor, the Andromeda galaxy. Andromeda is currently rushing toward us through deep space at 250,000 miles per hour, pulled by the mutual gravitational force between our two massive cosmic homes. When those two giant galaxies finally crash into each other, the sky above Earth will transform into a chaotic display of twisting light and shifting stellar streams. As Andromeda gets closer over the next few billion years, it will grow larger and brighter in our night sky, eventually stretching across the horizon like a giant glowing ring of fire. When the initial outer edges of both galaxies begin to merge, massive gravitational forces will throw millions of stars out of their normal orbits. The organized spiral arms of both galaxies will be torn apart, creating giant tidal tails of stars and gas that will stretch hundreds of thousands of light years into space. Nighttime on Earth will look like a magnificent, terrifying light show of cosmic destruction. During that future collision, billions of years from now, the individual stars of both galaxies will be thrown into completely new orbits across a single merged megagalaxy that scientists call Milky Way. Our own sun will almost certainly survive the galactic collision without physically hitting another star, but it could easily be kicked out into an entirely new neighborhood in the distant halo of the combined galaxy. Just like the ancient Methuselah star HD1229+1122, our solar system might one day end up floating in a distant, unfamiliar region of space, surviving the death and rebirth of the galaxy we call home today. Computer simulations created by astrophysicists show that there is a 50% chance our solar system will be swept out into a distant galactic tail during the merger. There is also a 12% chance that our sun will be kicked out of the combined galaxy entirely, sent drifting into the cold intergalactic void as an outcast world. If intelligent life still exists on Earth, or on constructed space habitats in our solar system at that time, our distant descendants might look up at a sky that is completely dark on one side, with the entire merged Milky Way galaxy glowing on the other side. That future scenario shows that our own solar system is bound to the exact same rules of galactic evolution that shaped the life of the Methuselah star. We are currently living in a peaceful era inside a stable galactic disk, but that peace is temporary on the massive scale of cosmic time. Galactic destruction and rebirth are necessary steps in the ongoing evolution of the universe, rearranging matter and creating new environments for future generations of stars and planets. If you find it fascinating that our own sun might one day become a halo wanderer like the Methuselah star, drop a comment below and share your thoughts. If you enjoy deep, accurate scientific stories like this, make sure to hit the subscribe button right now to stay connected with our channel. Looking at HD 1229+1122 reminds us of how deeply connected everything in the universe really is over vast stretches of time. The heavy elements that make up our planet, our homes, and our bodies, like the iron in our blood and the calcium in our bones, were formed inside ancient stars that lived and died billions of years ago. When we point a telescope at the Methuselah star, we are not just looking at a hot ball of hydrogen gas. We are looking at a living fossil that witnessed the birth of the very first stars in cosmic history. It survived the violent destruction of its original home galaxy, rode out billions of years of galactic collisions, and continues to shine brightly right in our local cosmic neighborhood today. It stands as a powerful testament to the incredible endurance of matter and the breathtaking scale of the universe we live in. No matter how much the cosmos changes around it, this lone ancient star keeps quietly flying through the dark, holding the secret history of a lost galaxy inside its light. The existence of this ancient survivor also gives scientists a vital tool for testing our fundamental laws of physics and cosmology. By studying its exact composition, rate of burning, and trajectory through space, researchers can test theories about dark matter, dark energy, and the expansion rate of the early universe. If our age estimates for Methuselah ever forced a total rewrite of cosmic history, it would show that human science is constantly growing, learning, and refining its understanding of reality. Every photon of light that leaves HD 1229+1122 and enters our telescopes on Earth has traveled across space for 190 years, carrying information from an era long before our world existed. It bridges the gap between the chaotic, hydrogen-filled universe of the Big Bang and the complex, chemistry-rich universe we inhabit today. To study this star is to look backward through a window into the absolute dawn of time, seeing the primitive building blocks that eventually made life on Earth possible. As telescopes get larger and more sophisticated, such as the James Webb Space Telescope and future ground-based mega-observatories, scientists hope to discover more hidden ancient wanderers hiding in the halo of the Milky Way. Each new fossil star discovered will add another piece to the giant puzzle of how our galaxy was built out of the smashed remnants of ancient worlds. The story of galactic cannibalism and stellar survival is still being written, with every new observation revealing deeper layers of our cosmic history. When you look up at the night sky tonight, take a moment to look toward the quiet constellation of Libra, and remember the humble yellow star flying through the dark at 800,000 miles per hour. Remember that it survived the catastrophic collapse of its birth world, lost its home galaxy, and outlived every neighbor it ever had, yet it continues to shine bright and steady in our sky. It reminds us that even in a universe ruled by giant collisions and terrifying destruction, beauty, stability, and survival are always possible. If you found this complete journey through cosmic history mind-blowing, please consider subscribing to the channel right now and clicking the notification bell so you never miss another deep space release. Drop a comment below answering this question. Do you think humanity will ever build space probes capable of visiting ancient halo stars like Methuselah, or will they forever remain beyond our reach? Do not forget to hit the like button and share this video on social media with anyone who loves true astronomy mysteries. Thank you so much for watching, and we will see you in the next investigation.